So yeah, hi Holman. I hear you. I saw your message. That's okay. You don't need to be connected on mic. All right, so I think we have everybody today. That's awesome. That's excellent. Let's review a couple of concepts that I thought were the key a couple of the key concepts that we reviewed from the last class. You don't have to do this. This is just a review of a couple of concepts that impact how a family behaves when it's nested into another one. And so just to remind what we're doing, we are creating a wall cabinet that it's made of different nested components. A nested component is a family nested inside another one. When you nest a family inside another one, you have the ability to connect some of the properties of that family into the host so that the values of the nested families are driven by host parameters. We started by creating a pool. Then this pool has 4 different types. This pool was brought inside a door. And it was locked and aligned to the left frame of the door. And then we were going to assemble the door, the pool, and the shelf inside a wall hosted family. And then we're going to try to make it parametric. All right, so all the files are on Google Drive. Now, let me review a couple of concepts. I'm just going to start a new. You don't have to do this. It's just a refresher of some concepts behind when working with nested families. I'm going to switch this to 3D, and I'm going to open the pool and switch to the 3D view of this pool. All right, this is the pool. And if you recall, this pool was created as a sweep, which is a profile along a path. And it was basically created on the floor plan of this family. The category of this family is generic model. And this family you can impact the way in which you manipulate this family and the host using these couple of concepts. All right, so let me show you this. If I just leave the family the way it is, and I load this into the project, here is the family. I'm going to zoom in. And the pool is getting placed on top of the active working plane. And the active working plane in this 3D view is the ground level. How do I know? If you go to the work plane and click show, that is the work plane, the active work plane. And that active work plane, it's level 1. Right? And so the way you create a family and place it into the project, it's you can just go into the component under the generated model, grab the pool of your choice, drag it and drop it. And notice that Revit doesn't ask you anything about the working plane that is going to be hosted. By default, it goes in the work plane that it's already selected. Now I'm going to do something else. I'm going to go to the floor plan of this project and switch to find, and then create a reference plane. And then this reference plane, I'm going to give it a name. I'm just going to call it sample. Then I'm going to go again into my 3D view. in the model. And I'm going to switch the work plane. So I'm going to set my working plane from level 1 to the sample reference plane that I just created. Notice how my working plane, now it's that horizontal plane. Now, what do you think happens when I bring my pool? Let's guess. Let's see what happens when I drag and drop. The pool, it's unaffected by changes in the work plane in the project. And there's a logic behind it. Let me show it to you. I'm going to go back to the pool family and investigate some of the properties of the family under these family category parameters button. So one of the properties of the family categories is this thing called always vertical. And then this checkbox, what it does is it forces the pool to align the reference plane, its reference plane, with the ground level of a project. So I'm going to disable the always vertical and load this into the project. I'm going to override existing version and see what happens now. So remember, I disabled that checkbox, and I'm going to drag and drop these. So it didn't do anything because there's, in addition to disabling the always vertical work plane, I also oh, my bad. Notice now that I have the ability to pick a different, when I select the pool, notice how I have the ability to pick a different host. And a host can be a different object. For example, if let's say I'm going to create an in-place mass, insert or architecture, component model in place, create a generic model, and then I'm just going to create an extrusion on the fly and finish. Okay, so these families, I'm gonna select, I'm gonna finish the model. Now I select these this pool, and notice that I have something called edit new host or pick new host. And then when you do that, I think the only thing I can do, the only thing I can pick are reference planes. Let me try this on a floor plan. I'm going to switch here to my floor plan. Or in elevations, south elevation. When I select this and I say pick new host, I can pick another level, and the pool will move from level 1 to another level. So picking new host is it's basically changing the reference plane that the family is hosted by. So that's pretty much what you can do only with that property. Now, what if I want these pools to be hosted by the face of these mass? So nothing inside the project, and nothing about this family allow me to rehost it to another object. And so I need to do a little change into the family so that I'm able to host it into a surface here. So I'll go back into the pool and go back to the family categories and parameters. And check this one. There's a checkbox here called work plane based. And what this does, it allow the family to choose what surface of other objects could be hosted by. And so I'm going to click OK here. I'm going to save it. Oh, yeah, I'm going to save it as I'm going to call this pool 2. And then I'm going to load this into the project. And I'm going to add that pool 2 into the project. Now, unlike the other one, notice that I can no longer have a free standing pool. Revit is asking me a specific host. And the host can be a work plane, or it could be the face of an object. And these options are only available if you enable the checkbox in the family that is called workplace, work plane based. Work plane based. That is this checkbox that a checkbox property. All right, and you can pick a face, and when you do the face, notice how it align to the surface. Or you can select a work plane, and in the work plane you have the list of all the work planes that I have created in the project. Remember the reference plane, the sample that I created, and now this is aligning it with that work plane. So it gives you greater flexibility about where to place objects, whereas the other one, the one that is not work plane based, it will only snap to the ground level. You will not have the ability to host it into other surfaces. And so that concept, it's important because when you create custom content, you have to decide the behavior the family is going to have in the host. Whether you want it always, furniture, for example, you're never going to have furniture snap to the side of a wall. So those type of families, just leave them as is. No need to be work plane based. Well, let's say you want you create a telephone or a lamp or a desk lamp, and you know they're going to be hosted by a surface. Then make sure that when that family is created, that we enable the work plane based property available under the family categories and parameters. Okay. Any question about this? Because I think I explained this in greater detail before to Josie, but I did not explain to the rest of the class. All right, so let's close this. Let's start pulling together everything together. Let's pull everything into a single family. All right, so just what we're going to do now is assemble everything. I'm just going to give you a screenshot of what we're going to do. We're going to, last class, we end up creating the pool. Then the pool was brought into the door. And what we're going to do today is create a wall-based family. We're going to nest the door inside the wall cabinet. And then we're going to add a shelf. And I'm going to rate it vertically. Vertical again. All right. Put this away. Okay, so let's start a new family. In this family, we're going to call it, we're going to pick the casework template under the English Imperial. Oh, you know, but I started wrong. I need to pick a wall-based generic family. So my bad. Let's close this family. You can just go File, Close, and do not save it. It's important to pick the right template. So create again, new family, English Imperial, and let's do the casework wall base. That's the one I want. And a wall face family, it's a family that it's only going to be created in a project if there is a wall host. Examples of wall-based families are the doors or the windows. They need a partition in order to be created. And so the same is going to be with this piece of casework. Not all casework needs to be wall hosted. This is just to teach you what's possible. In fact, I think one of the dangers of using wall hosted elements is that if the wall disappears, all the elements go with it. And that's true with doors and windows. Right? You delete a wall, all the windows and doors hosted by that wall will disappear. And so notice how this family in the floor plan, in the reference plan, has a placement side and a back side. And what we need to do is to create a let me sketch it here. Where's my cursor? All right, so what we're going to do is to create a big box. It's a solid extrusion, but then we're going to carve it out with another solid. This void solid is going to be an inch away from the surfaces, and it's basically going to cut the 3D solid and make a space for the shelves. Then we're going to add the doors. Then we're going to mirror the door. We're going to lock the nested properties of the door with the family parameters. Yeah, and then we're going to add the shelf. So let's start by creating the appropriate offsets. We're going to create a new reference plane. You can go into Create tab, reference plane, and let's do this together. Again, stop me if you are falling behind. A reference plane, and I'm going to offset the boundaries of the casework 1 inch inside in. So I'm going to create this. I'm not going to worry about the distance right now. I'm just creating the appropriate offsets. What I'm doing is create 4 different reference planes up on every dimension, on every side of the solid. Easy, you go to create, and then you go a reference plane. Don't pick reference line. That's a different animal. Reference line are intended to derive other geometries by hosting them in the work planes. It's like a collection of reference planes, but reference planes is just a single reference plane. All right, so I created this one. I created this one. I created this one here, and I also created that one. Now these are need to be placed an inch away. Select the reference plane, and you see this temporary dimension that appears when you select it. I'm going to override the value and change the value to 1 inch. And I'm going to do the same for all of them. So select the innermost face, click on the reference plane, change this to 1, select the back reference plane. Notice this one, it's a little more tricky to control because they're temporary dimensions by default try to align with a datum object. It's not like picking it from the face. And what you can do is when you select this reference plane, just grab the temporary dimension, actually called a witness line. So if you hover over the grip of this temporary dimension, you can snap it to a different, or I guess like, I thought I could. Oh, I had to click the tab. So let me show you again. This was 1. Then I selected this, and if you click on the move witness line and snap to wanted to snap to the face, in order to pick the face of the wall, I just hit tab, and you see how it pre-highlights, and I release. Then I'm going to do this again, 1 inch. Or another thing you can do is just create a dimension and then select the reference plane and change the dimension value to 1. So different ways of doing the same thing. You can do it using the temporary dimensions or create a dimension, select the object and change the value. All right, so I have 1 inch offset around all the work planes that are defining my outer cabinet. Now I need to make sure that these dimensions remain as 1 inch regardless of changing in the width and depth. So select we're going to place dimensions. I'm going to change this scale to 1 = 1 so that the text is a little more readable. And then I'm going to create dimensions. Go to the dimension tool. It's the align dimension in the upper left side. We can also go into the annotate tab, align dimension. I'm going to create 1 inch dimensions on every direction. And again, at the bottom side, make sure you hit the tab key in order to pick a different reference plane. And these 4 dimensions that are sitting all around the boundaries, I need to lock them. So to create dimensional constraints, just hit the lock that appears when you select the dimension. And I'm going to do that for the 4 sides. So lock it here, lock it here, lock it here, lock it here. And so I can make changes to the length and the width, and it should not be, this offset will remain constant. So length, let's change it to 3, apply, and notice how the reference plane's offsets remain as is. So notice also how the template disclose the width, depth, height, and length parameter. For consistency, I don't know if you agree with me, but a cabinet is usually, when we measure cabinets, we usually refer to width, depth, and height. And so, however, when you select these parameter is automatically associated with the length label. And what I'm going to do, I want you to do is to swap it with the width one. And so open the family and types again, and let's give the width a value of 4. And then all you need to do now is select the length parameter. Oh, Melissa, I just saw your note. This was about changing the dimensions. That is a great tip. You can also, when you have a temporary dimension, like here, well, I no longer have it because I converted into permanent one. You can just double click on the witness point. Not on the permanent ones, just on temporary ones. Okay, so I'm going to select the length and just swap it. To swap a label, click on this drop-down list and change it to width. It just makes more sense that we refer to the width cabinet in that direction. Then this is the depth. And then let's take a look at the left side. You just open in the elevation, the left side. All right, so this wall cabinet, this is the side view of the cabinet, and notice how the height is associated with a spot on the ground. I'm going to do two things here. It's important for me to understand what is the default value for a wall-mounted cabinet. And in addition to that, I want to be able to select what is the height. And so I need to swap a couple of default parameters in order to make that happen. So I'm going to select the height parameter here. And I'm going to swap this to the parameter called default elevation. Default elevation. And what this is going to allow me to do is that when I place this wall cabinet on the project, it's automatically going to be placed X value above the ground. The default value, you can override it in the family types. So going to the family types and change the default elevation to, let's change it to 5 feet. And apply it. Notice how now the default elevation, or if you're a short person, maybe we can just do it 4.6. All right, that's the default height of the cabinet. And why I'm doing this, these are another thing about you guys need to know about templates is that I did not create these parameters. These parameters were provided to me by the templates. And all these parameters cannot be deleted from the project. So if I select these default elevation, notice how the delete, it's disabled because it's a system family, and a system family comes with the family template. And the only thing you can do is reassign them or leave them inactive. What do you mean inactive? Meaning that it's snapping to a reference plane that is not used by anything in the project. So if you're not happy with the default reference planes, just leave them inactive. For example, the length one, we're not going to use it. So it is going to remain inactive. Can I delete it? No, I cannot. Can I? Oh, it allowed me to delete it. That's strange. So I delete the length dimension. I thought it was a family parameter. Oh, you know, the length is not, but the others are. So look at the height, depth, and width. Look how you cannot delete those three, those comms. Those are system parameters. And the same with the default elevation. Notice how the delete parameter is not an option available to me. Okay, so I have I have made changes to the default elevation. I'm going to create another reference plane, RP. And yeah, Holman, the length was originally assigned into the template, but it didn't seem like it was a system parameter, system family. System families are the only ones that you cannot delete. So for some reason, this template had an additional custom created parameter, and I was able to delete. Yeah. All right, so we were in the left view, and I'm going to create I created a new reference plane above. I'm going to make sure to give it a name. So this is the bottom of the cabinet. So select this reference plane and change the name. You know, the name, it says identity data. Bottom, I'm just going to call it bottom. And then the full reference reference type is going to be the bottom one. This reference is just a way for Revit to confirm the strong behaviors of this reference plane. Okay, then I'm going to select the one at the very top, and I'm going to give it the name just top, and make that reference have a strong definition and associated with the top. So I have two reference planes with a name, and now I'm going to create a dimension. And this dimension, it's going to define the cabinet height. So in a nutshell, what I did is change the height from the bottom to a new reference plane. So I'm going to select this dimension and change its label properties to the height parameter. And let's flex it very quickly. So if I change the default elevation to 4, notice how the height is dragged down. But I'm going to leave this to 4.6, the full cabinet, wall cabinet height. And then the height is going to be 3 feet. Okay, so I think we have the framework here. Yeah, we have, on the left side, I also need to add the thickness of the top and bottom material. So I'm going to create a reference plane. So create tab, reference plane. And make an offset above the top and give it a 1-inch offset. And let's do another one at the bottom. Select the reference plane and change the temporary dimension to 1. And then I'm going to create a dimension and lock it. Create a dimensional constraint so that no matter the size of the outer envelope, the offset is always going to be 1 inch in. And let's now place the constraint. Let's create a line dimension accessible in the quick access bar. The third click is a placement click, and lock it. And let's do the same at the bottom side. First click, second click, the third click is a placement click, and lock it. And so these, regardless of the height of the cabinet, the offsets are gonna kept consistently, are gonna be kept consistently at 1 inch. Okay, so I have the framework of the solid. I'm gonna build it now, and then I'm going to build the interior one, and basically cut the void of the exterior with the interior. So another thing I'm going to make sure that I respect is that this is the location of the doors. It is one door, this is the other door. So my solid is actually going to start from this work plane, and it's going to snap to the wall reference plane. All right, so it's very simple. What we're going to do, we're going to create a solid, and then this solid is going to be cut by another solid, and that's going to create the whole body. And we don't have to create like individual panels on each side of the cabinet. So let's create an extrusion. The extrusion is going to be hosted by the reference level. But maybe I want to change that. I don't want the reference level to be the host of the sketch lines. I actually want it to be the bottom work plane. So in the set button, let's change this to the reference plane button. This is why it's important to give reference planes a name, because in this drop-down list, we're only going to see reference planes that have a name associated with that. If you fail to add these to name the reference plane, just go back very quickly to the left view, select the reference plane, and give it a name. So reference plane bottom, and that's the work plane that's going to host the extrusion lines. And as you go and do a rectangle, it's probably easier thing to do. Do a rectangle, and I'm going to snap from the intersections. Remember, you can just type on the fly SI to pick intersection points. So I'm going to do the intersection on the lower left side. And then I'm going to snap to a point of 1 inch offset. You don't want to do it all the way to the right or the left reference plane. You want to do it 1 inch offset because I'm allowing the door to take that inch thickness. So make sure you snap the intersection to the appropriate, to this point. Okay. I am going to, I'm going to finish here, and then I'm going to switch to the left view to fix the vertical alignments of this family. So notice how I have the form which correctly snaps in X and Y, but now I need to lock the top and the bottom with our reference plane. So Melissa, I saw your note there. For the bottom reference plane to show in that drop-down list, go to the left view, select this reference plane I highlighted on the screen, and give it the name bottom. You have to actually type it. It's not enough to give it a reference type. You have to actually type it. And the same is true with this one. This is the top. If you have not done this, select the top reference plane and type it. Give it an identity data. Give it the name of top. You have to type it. All right, and what I'm going to do is make sure that this solid snaps to the top and bottom reference planes. So grab the handle from the top and snap it to the top reference plane and lock it. This is an alignment, a vertical alignment. And the same I'm going to do with the bottom one. Make sure you grab the lower handle and snap it to the reference plane and lock it. This lock is only going to appear right after you release the handle. If you missed it, then you have to do it again. Remove constraint, drag it and snap it, and then lock it. So let's very quickly check it out in a 3D. And this is the placement side. And let's see if this respond to different changes in parameter values. I'm going to change this to 4, 1, and 2. There you go. Change the fold elevation. You can see how I can lower it. I can raise it. I'm going to leave it at 4.6. The height, I'm going to leave it at 4, 1'6", and the width is 3. Typical size. All right. This is flexing and it works for me. I hope it works on your end. And if things are not flexing, it's probably we're missing an appropriate constraint. So in the floor plan, in the reference plane, make sure you have this. And in the you have the depth, and then you have the width. And in the left side, make sure you have the height and the fold elevation correctly associated. Okay, so just a couple of pointers here. If you switch to the floor plan, notice that the solid is not visible. If you're wondering why it's not visible, think for a second, why is this not visible? Well, for once, all views inside families have view ranges, and the default view range for a family in floor plan, it's a cut plane at 4 foot high. And so because the default elevation is above 4'6", then I cannot see the cabinet solid above that cut plane. Now notice when I lower this to 3 feet, it's starting to be visible. But I want to keep the 4'6", and I still want to be able to see the solid in this work view. So what do? Well, let's change the view range inside a family. So this is not that obvious for a user, but you can access the view range of a family if you switch this drop-down list on the left side and change it to display the properties of the view. So switch the display of parameters to the floor plan, and now you have properties of the view that includes the view range. So change the view range, and we're going to raise the cut plane to 5 feet and hit OK. And now my solid is visible again. Right. Now, let's go back to the family parameters by switching these drop-down lists. Okay. Any question here? Is this good pace? Are you falling behind? Hopefully not. Let me know. On a 3D view, so what's next? We're going to define the material of this solid. And we're going to make sure that somebody in the project has the ability to change it. Then we're going to carve out the solid with another solid. And we're going to basically make the hole out of it. Then we're going to bring the doors and we're going to bring the shelves. Okay, so let's talk about the material first. So this piece of solid material has material is called by category. And like I say in the last class, when material is by category, it will inherit the default material in object styles in the host project. But one of my recommendations is to allow the families to define a material in the project by creating associated parameters. And so last class, I also discussed that you can create an associate parameter to a material and then let the user decide what the material is going to be in the project, because every project is different. You may or may not choose the same type of wood or the same type of metal. And then you can allow the user to pick the finish of the material in the project and not bake it in the family. So I'm going to click on, again, select the solid, click the associate button, associate parameter button, and I'm going to create a new parameter of the material type. And I'm going to call it cabinet material. Cabinet underscore material. And it's a type parameter, automatically comes preloaded with these default values, which are okay. It's a family parameter. And hit OK and hit OK. All right, so now when I look at the family types, notice how the family material is a type parameter. When I load this family into the project, the user can change it in the project. You don't have to define it in the family environment. Okay, the next step, let's create the solid. The void, I'm gonna cut this one. So let's go back again into the reference level. And I'm going to create a solid, and that solid is going to be created along this path. It's an extrusion. It's going to have a width, a height, and a depth. And then I'm going to use the cut command to cut the void from the solid. All right, let's do it. Go to the Create tab. And then I'm going to create a void form, a void extrusion. And again, to make it easier, I'm going to select a rectangle in the draw tools. And then use snap to the reference plane, the inside of the cabinet faces. This is that work plane. That is that face. And then snap it to the face of the face of the cabinet. Now make sure that you kept the offset in place, right? Because the doors are going to be placed right here. And I don't want the void to overlap with the doors. So that's why I am creating this void element an inch away from the front reference plane. All right, that's it. If you snap to reference plane, there's no need to lock this sketch lines. And notice how the work plane defaults to the bottom. So I'm going to hit the green checkbox here. And then I'm going to switch to the left side and make sure that I adjust the top and bottom faces. So let's start with the top. Grab the interior void top face and snap it to the underside of the cabinet. And grab the lower face of the cabinet and snap it to the interior thickness. And you need to lock it. I forgot to lock it. Again, you snap it to the reference plane and lock it. Here is the lock. Locking is super important because it's gonna force the shape to be driven by the framework. And do the same for the bottom. I'm gonna snap to the reference plane. And lock it. Give me a second, guys. Okay, I'm back. This is the void. Notice when you select this element, it's identified as a void. It also has this checkbox that it's indicate that it cuts geometry. Now, when I switch this to 3D view, the hole should be done automatically for you. I'm going to switch this to shaded so you can see the cabinet should have been cut by this void. In the event, that this doesn't cut a hole, that means you can use the cut command. Cut the solid to be. If you follow the instructions here, it will tell you. Select the solid to be cut, and then select the solid that's cutting. But if you follow my instructions, I think it will cut automatically the hole for you. So there's a question from Paige. Why did I have to lock this two, but not the previous two? Good catch. When I edit extrusions and I snap to reference planes, like I'm doing right now, you see how it snaps to reference plane? Revit automatically create locks to these, to all the four reference plan, all the four reference. But that behavior only works with the sketch line. And the extrusion doesn't have sketch lines in the vertical side. So I did not snap the bottom or the top of the extrusion to any reference plane. And that's why they don't lock to anything. So that's why I need to, the one in the floor plans automatically snaps to the framework because the sketch line are snapping to it. But in elevation, I did not have anything to lock the vertical on the bottom. And that's why I have to manually drag the shape handle and lock it there. So hopefully that explains it. All right, so hopefully everybody with me here. I have, let's just flex it and test it. If the height is 5 feet, depth is 2 feet, width is 2 feet. It seems to be working on my end. So I'm going to default it 216. Depth is depth is 16, width is 3, and height is 4. And the full elevation, you can also flex it if you want. There it goes. 4, 6. All right, so my cage, my cabinet cage is ready. Now I need to load the doors with the pulls and the shelf. Uh, so I'm just gonna save it in case you always want to save it often. I haven't saved this in a while. I'm gonna call this cabinet body, or just a cabinet. It's a cabinet, wall cabinet, wall and store cabinet, because this is the final one. All right, make sure that everything is flexed, that things are tested before we load it. Last class, we created the door and the doors were flexing, the pulls were flexing correct. But flex is the key. So now we're going to add the doors. So in the reference plane, the door is going to come aligned with a work plane. And so we need to make sure that we give the appropriate name to the reference plane. So the door is going to be hosted by this work plane, right? And so select the work plane you see on the screen, and let's type a name for it. I'm going to call it door work plane. And so I'll be able to select the door, to select this reference plane if I need to. And you know, the directions of the reference planes are driven by the way you create them. So let me ask you what I'm talking about. When you create a reference plane and you do it from the left to the right, the positive side of the reference plane is this one, and this is the negative side. So if I bring a family, the family of the doors is going to be hosted right here at the top. But if I create, again, I'm going to delete this guy. If I create a reference plane from the right to the left, then the directions inverse. So this is this is going to be the positive side, and this is the negative side. And so when you bring the door inside Revit, then the door is going to be in the positive side of this work plane. Okay, I have a question on a reaction from Kelly. Void extrusion was only in pitch line. Okay, I know what you're talking about. So if what's happening is the void is not cutting the is not cutting it. So let me show you. When we create an extrusion, and I'm going to create an extrusion here on the side, and then I change it from solid to void, then you get this peach color. And so if you guys have the peach color, you have to cut it. So cut from where, from this extrusion, the void. And that should do it. That should do it for you, Kelly. Let me know if that works. Another question from Melissa. How can you tell if the reference plane was made in the correct direction? Once the reference plane is created, there's no visual indication what is the direction, unfortunately. It's one of the things you need to think in advance, or and there's no like a command that flips it automatically. And so your choices are either deleted and recreated. If it's not working, you're basically going to test it when you bring the family you're going to host it in. But for example, here, even myself, I don't recall how I created this one. But I usually tend, and if you can make yourself this habit of creating everything in this direction, in the positive side, so that if you do it the other side, then know that your directions are going to be inverted. But yeah, that's a good feedback for us in AutoCAD, Autodesk. We need to find a way to reverse reference planes. or indicate what is the correct direction. Okay, so hopefully that worked for you, Kelly. And there's another Nicole. The positive side is in the opposite side of the reference plane name. Oh, that's a good tip. Let's see. Let's see. So if I create a, see, yeah. So notice how the reference plane name, it's below. It's on the negative side of the reference plane. If you hit this one, which I created in the other direction, notice how it's different. So I am anticipating. Yeah, this should work. Good tip, Mikal. Thanks for pointing that out. There you go. That's the answer. So if the name is above, the reference plane positive side is below. And then the opposite is true for the reverse. All right, so let's bring the doors. We took care of the material already. So when this material, it's when you select the solid, it's automatically associated with the cabinet material. So I'm going to switch to the elevation placement side. And I'm going to bring here the, or you know, I'm going to switch to a 3D view here. And I'm going to bring the doors. So go to the Insert tab, Load Family, navigate to the place you saved the doors in the last class. If you were not here in the last class, just bring the door from the Google Drive. So mine, it's at fall. So this door panel. And then the door panel will be available under the casework category, and select the type in the project browser, drag it and drop it. And notice how, because this family, it's face-based, you can snap it to any work plane, any face of a work plane. So make sure you select like the top face of the, like the outer face of the solid, and let's just place it there. And again, the reason this is like this is because when I created this family, I make it work plane based. If this is checkbox is disabled, then that behavior will not be available to you either. Okay, so that's this is the door. I'm going to go to the placement side elevation. And what I need to do now is to control the size of this door given the host parameters. So the height of the door is going to be equal to the height of the cabinet. And the width of the door is going to equal to half the size of the cabinet. You agree? All right, the way to make that connection is to access the type properties. Select the door, edit the type, and in the height of the door, we're going to associate the height of the door with a parameter in the host project. So click the associate button, is that little button next to the value. And you're going to say that the height of the door equals the height of the cabinet. A grays out. And then I need to create another parameter, which is going to be called door width. And I can create a new parameter by clicking these associate 5 parameters. So the width of the door panel, hit the associate family parameter button. And I'm going to create a new parameter. And this new parameter is a type parameter, is dimensional, goes under dimension. And I'm going to call it door underscore width. And then hit OK. Now that parameter I just created, it's accessible using the family types here. Here's the door width. You want me to repeat it? I guess it was straightforward. You just select the door, edit the type. You can create a new parameter by associating a parameter here, and I hit this little button, new parameter. I just added the door width, keep the rest of the properties as default. And then when you apply it, you can access it again under the family types. And you can add embedded formulas in the family types using existing values. And so in this case, the door width is the width divided by 2. Now, make sure that for this to work, that you type the parameter exactly the same way it's spelled in the dimensions. In general, if I fail it, if I, for example, just type width, notice how I get this message that the parameter does not exist. So make sure that they are case sensitive and that you transfer exactly the same way it's spelled out. There you go. So now the door width is exactly the width of the cabinet divided by 2. So when I flex this, for example, 4, then the doors change as well. So that's the beauty of nesting parameter values. And now all I need to do is to block and align and mirror it. So align, I'm going to do it in the horizontal and then on the vertical, and then I'm going to mirror that component and align and lock 2 times in X and Y. The lock has to happen in both directions, in the X and the Y. So align to the left, the face of the door, and lock it. And align to the bottom of the reference plane, the bottom of the plane, and lock it. I'm going to mirror now this component, and I'm going to lock it also in the X and the Y. But let's mirror it first. Select the door, use the mirror pick axis because the axis is already there. Mirror this component. Select the axis of reflection. There you go. Escape. Cancel. And I need to lock this door. So align to the bottom of the reference plane, the bottom of the door, and lock it. And align to the right side of the reference plane, the right side of the door, and lock it. All right, so if we follow this correctly, now it's time to flex it. So you go to reference plane, to the family types, and change the width. Now the width is 4. There you go. Height is 3. So you can now start thinking, building all the different types of wall cabinets with all the different changes in parameter value. And this should work seamlessly.
Is there a reason why you aligned it to the bottom? Could we just do it to the top as well? Does it matter?
Yeah, you
Oh,
can do
okay.
it to the top. It doesn't matter, really.
Just one of them. Yeah.
Just one of them. But don't do it to both of them, because then you're gonna receive a message that the geometry is overly constrained.
Okay.
Is it trying to get pulled in two different directions? Although that never happened because it's driven by the height. But that's why. You could do it to the top as well, or you could use the center for both of them. Align the center for both of them. All right. Let's now take care of the shelf. And for this, let me just refresh the concept of an array. I don't know if a lot of you already know how to build arrays, but you don't have to do this. This is just to refresh the concept. So I just created a default project, and I'm going to bring a furniture. Oh, there's no furniture in the out of the box here. Let me load a piece of furniture here. Insert, load family. Oh, let's use the pool. And then okay, this is a pool. And I just brought it to demonstrate the concept of array. When we do a linear array, this is the array button in the modify tab. You can do arrays using two methods. Well, you define how many instances you want to create, and then you define the method. You can create an array by defining the distance between the first element and the second element. Or you can create it using the distance between the first one and the last element, and then distribute the elements equally between the first and the last one. So let's use the first one. When you create an array using the second method, you define the distance between the first element and the second element. This is my second element. And then I define, let's say I'm going to create 10 elements of this. That is an array of 10 elements. And what you define here is the distance between the first element and the second element. So when you use the array command, I'm going to select it. When you use the array command, that's what move to second means. Move to second means define the distance between the first element and the second. So that is this button. Now, the other method is define the distance between the first element and the last element. So this is the distance. And then distribute an equal number of instances in between them. So in that example, you select the pool, array it, use the last element, and then define the distance between the first one and the last, and make a number of instances. There you go. So it's exactly the same result, but different methods. That makes sense? Now, the other thing is that when you create an array, the array becomes a group. So each instance that it's arrayed, it's called an array model group 2. And notice when you select the array, there is a parameter that highlights. This is the number of instances. And you can just type on the fly and change the number of instances you need. The same here. And notice how you achieve different results depending on the method. So in this method, I need 4 instances, uses the distance between 1 and 2. In this case, I have 4 instances using the distance between the first one and the last one. That makes sense? I know for a lot of you, this is already a given, but maybe for some of you is not. So the reason this is important is because when we create our shelf distribution, we need to choose how we're going to rate it. And what I'm going to do is, this is the cage of the shelf. This is my first shelf, and this is going to meet my last shelf, first and last. And then I'm going to make sure that the distance between this distance, it's so hard to sketch in using the mouse, that this distance is equal to this distance, and it's equal to all these distances. Distance, 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 and the number of instances is going to be called n. So again, I'm going to use the method from first to last. I'm going to use a parameter called n and another one called n plus 2, which is going to be the total height of the element. And so all I need to, I'm going to convert the number of instances into a parameter, and then the user is going to be able to change n as needed. All right, so I'm going to close this project, and let's go back to our cabinet. And I'm going to the floor plan, and let's make sure that our active work plane is the bottom work plane. So create, set reference plane button, hit OK. This is going to give the shelf the right elevation. And then insert from the load into the project, sorry, load family. And let's bring the shelf family. And this shelf, I think we created the very first class, but it's also available in the Google Drive. So if you don't have it, go into the Google Drive right now and you can just download it. If you missed the very first class, that's where we created it. I'm gonna bring this shelf, and then the shelf is gonna be available under the casework category in the family browser. And grab the type and drag it into the project. I'm just gonna snap it to the center for now, because there are things I need to do to these shelf. So this shelf, let's look at the parameters, the type parameters. You can just select it and hit the edit type. And it has a depth, a height, and a width. And the depth, height, and width is going to be a factor of the overall casework. So if you think about it, the width of the shelf is going to be equal the width of the cabinet minus 2 inches. Do you agree? I'm subtracting the thickness of the side panels. And then the depth of the shelf is going to be the depth of a cabinet minus 2 inches too, right? Minus the front thickness, minus the back thickness. And those are a couple of parameters I need to define in this project. And then I'm going to reconnect I'm going to associate the depth and the length of the depth and the width of the panel to the host parameters. Well, let's start by defining those parameters. So I'm going to go into the family types, and I'm going to create a couple of more parameters. Here's where you add additional parameters. Oh, Melissa, I do not have a version of 2020, but if you, it should be very easy to you. If you create a new family using the casework, just the generic casework one, just create a rectangle with a 1-inch thickness, snap to the corners and save it. It's super easy, super easy. Oh, and maybe connect the solid material with new material, because we want the materials to be consistent. Okay, so we need to create a parameter for the shelf width and the shelf depth. So let's go into the family types. I'm going to add a couple of new parameters. This one is going to be shelf underscore width. And it's a type parameter. Left the rest of the parameters the same. And I'm going to add another one, shelf depth underscore depth. All right, notice how these parameters are organized alphabetically using the first letter within the group. You can modify this by using these move parameters up and down. So if I want like the shelf parameters to come right after the cabinet ones, you can just use this move parameter down. And I'm going to select the width. I'm going to move it down as well. So I start with the door, then the cabinet parameters, the shelf parameters. So use these to rearrange the relative location of the parameter in the family types. You can, if you want to reset it, you can also sort it back in the descending order. And this is by group. So this is one group. This is another group. You have to apply it per group. Okay, I have my shelf width and my shelf depth. And what I was saying earlier is that the shelf width is going to be the cabinet width minus 2 inches. And the shelf depth is going to be the depth of the cabinet minus 2 inches. You agree? The 2 inches accommodates the thickness of the panels on the sides. And then hit apply, hit OK. And now I need to associate the shelf parameters with the host parameters. So the shelf that's on the screen, hit edit type. And the depth of the shelf, I'm going to associate it with the shelf depth. And the width of the shelf, I'm going to associate it. Again, hit the right side button in the parameter value, and it's going to be associated with the shelf width. And that's it. Oh, and here's another one. The shelf material, which it's built into the family, we're going to connect it with the cabinet material. So this is just as on my end, I'm designing this shelf materials to be exactly the same as the body material. If you don't want that, you don't have to, or you can create another material to have a different shelf material. For this exercise, I thought the cabinet material and the shelf materials were going to be the same, but you can create another parameter if you need to. So 3 nested parameters are associated with host parameters. Again, just repeating quickly, hit the associate button on the shelf and connect to the shelf depth. Hit the width button and associate with the shelf width, and select the shelf material and connect it with the cabinet material. Apply OK. And now this shelf, it's the right size. And I believe it's right, it's located in the right place in the horizontal, in the vertical. I'm going to check that, but I need to lock it in X, Y, and Z. So I'm going to align it where it needs to be. Let's fix it in the, I'm going to move it here. Let's fix it in the right direction. Again, you can pick any reference plane. I'm just picking the right one. So align to this reference plane, the face of the shelf, and lock it. Align to the back face of the cabinet, the shelf face, and lock it. And then look at in the left side. Oh, look at my work plane didn't work. So it's at the bottom. So I need again to raise these up. So let's pick a new host. Pick a new host. Didn't work. I'm just going to move it manually, vertically. I don't want to lock it yet because, you know, these the bottom and the top cap of the cabinets are already there. And so what's going to happen is that I need to create an array from my work plane to another work plane and make sure that the distances are correct. So here is my shelf. The height is not yet defined, but when I look at this in the front view, in the placement side, here it is. That's what I needed. Right now it's locked on the X and Y, but it's not yet locked in Z. Okay, so hopefully everybody with me here. Here it's where we're going to start using additional parameters and additional formulas in parameters. So in a nutshell, I'm going to sketch what we're going to do. I'm going to add a new reference plane here. And I'm going to add another reference plane right here. Then the distance between these distances is going to be called the shelf space. Shelf space. And the distance from here is going to be also called D. It's going to be shelf space. The shelf space also is going to be a formula. This is the height, right? So the height divided by n, where n is the number of spaces, is going to be D. You agree with that? So the height divided by a number of instances is going to be D. So I also need to create this parameter, and it's going to be a constant. And it's a constant that is going to be defined by the user. The user is going to define how many spaces he needs for his shelf. But this could be 1, this could be 2, 3, 4, and 5, etc. And then the array, this is the number of instances in the array. I'm going to call it AN. The array is going to be the number of instances minus 2. Hopefully this makes sense. It seems a little complicated, but really it's just simple math about distribution of elements. So let's create the parameters that I need for this equation, for this distribution. So let's go to the family types. And I'm going to add an additional parameter. So hit this little button, create a new parameter. And let's start with the number of shelves, with number of spacing, n underscore spaces. So is the number of, the number of vertical subdivisions, that's what it is. And this is going to be a integer. I don't need decimals in this equation. And they're going to be placed under the other group. That's fine. So I have the number of spaces. And by default, I'm just going to add 3 here. I'm going to add another parameter, which is going to be the array spaces. Array spaces. The type parameter as well, and it's going to be an integer as well. This is important. If you miss this step, then this is going to create a length parameter, and you won't be able to use it in the array formulas. So make sure that you switch to integers, and it's under others, and then you hit OK here. All right, and I'm just going to leave this as 3 as well. Okay, then I'm going to also, I think those are all I need, because I have, I need the shelf space. So let's add another one, a new parameter. And I'm going to put called s underscore spacing, shelf spacing. And this is a length parameter, but I'm going to put it with the other as well, so that it's separated from the other parameters. It's a type parameter and its length. Make sure we identify it as a length parameter. Oh boy. And all right, so the shelf spacing, it's going to be the height divided by the number of spaces, and make sure you type it exactly the same way. These are case sensitive. And then the number of spaces, if it changes, you can see how the spacing is getting. The more spaces, smaller the spacing, right? And then the array spaces is the number of instances I'm going to copy the I'm going to create the array. And so the number of spaces is going to be n spaces minus 1, I think. Yeah, minus 1. It will be 1, 2, 3. No, minus 2. Because we, in a nutshell, the number of arrays, this is the number of array, and the array number, and then this is the total n. So n minus 2 is the number of spaces. So I'm going to put the number of spaces, keep it at 4, and the number of spaces I'm going to keep it in 2. Then apply, and then hit OK. And I think I'm ready to put everything together. This is the last step, and this is make sure that the array is placed correctly. So let's create a new reference, two more reference plane. This one, and let's create another one a distance away from the top. So the ones at the bottom, I'm going to give it a name, and this is I'm going to call it shelf underscore first. And this is the first shelf. And then I'm going to select the other one. I'm going to call this shelf underscore last. Now I'm going to create dimensional constraints. I'm going to create a dimension from here to here and place it. Another dimension from here to here and place it. This is D, which is the distance between shelves, is the shelf space. So I'm going to convert those two parameters, those two dimensions into parameters. And I'm going to have to speed a little bit because I'm running out of time. Why not dimension it from the side of the cabinet? Because the shelf space, the way I define it, it's from top of the shelf to another top of a shelf. And so if I want the space to be equal, like I'm going to call this X. If this space needs to be exactly the same as the next one, I need to account for the exterior thickness. If that makes sense. All right, so I'm going to select this dimension and I'm going to associate with the shelf spacing. Yes. Maybe I'll change the scale to 1.5 so that it's more readable. And this is going to be also the shelf spacing. All right, so if you remember the array method that I was using, this is going to be the first item, and this is going to be the last item, the first and the last. And then I'm going to array it a number of times n. And n equals big N minus 2. That makes sense? All right, so now I need to lock this reference plane with the top of the spacing one. So align to the reference plane, the top of the shelf, and lock it. Locking it's important. And then in X and Z, I already have it aligned. So let's see how this behaves if I change heights. So if the cabinet is 5 feet, if the cabinet is 3 feet, it's equally spaced. That was the goal. If the height is 4 feet, the shelf spacing adjusts automatically. And now I just finished the last step is to finish the array. Select the shelf, array it, and it's going to be from the first to the last. So the distance is from this reference plane to the last one. And the number of items is 2. Enter. Let's see, 3, 4. So in the array spaces, yeah, okay. So I created this array. Notice that this value, I mean, I can change it manually, but I don't want to manually change this. I want the formula to drive this n value. And what I do is I select the number array dimension, and associate with the array spaces. And let's see, I think I need to change this to 1. Yeah, so the array spaces is n spaces minus 1. So let's flex it. I have the array here, and n spaces, it's 5. Oh, I need to lock it. I forgot to lock it. You see, that's why it's important to align and lock. So I'm going to align to the last one, and lock it. Again, the user needs to change is the n spaces. Let's n space 3, 4, 5. I think that is working great. All right, so this is it. This is my parametric cabinet. It's well hosted. Now let's just flex a final time for everything. The height, it's 5. And notice how the shelf automatically distribute. The height is 4. The number of spaces, which is the one I'm going to change, it's 5, 6. Maybe that's too tight. 7. And you can change the width. And everything works fully parametrically. Now, the last step is to create types. You go to the family types and start building new types. Here you can say, okay, this is going to be 3 by 36 inches by 36 inches by depth, sorry, width, depth, and height. By 18 inches by 36 with 2 shelves, with 4 shelves. This is my first type. And make sure you reflect the values of the name in the types. So 3 feet by 3 feet in height by 1.6 and 4 shelves. The number of shelves is the array space. So this needs to be 5. There you go. This is my first type. 4 shelves. Let's add another one. Let's do one that's 42 inches by 18 inches by 36. And let's make this, instead of 4 shelves, let's make this 3 shelves. So width 42 inches, depth 163, and the number of shelves is 3. So this needs to be 4. Apply. That's another type. And keep adding, keep adding. You can build your whole library of wall hosted cabinets here. Save it. Also tested that, you know, when I switch this to fine in the different orientations, for example, the backs in the front side, in the placement side, when it's fine, it only displays a single line. When it's coarse, it should display the full thing, but I don't know. Oh, fine here. When it's fine, it displays the full elements. And when it's coarse, it only displayed as a line. And then also displayed in floor plan. Let's see how things display in floor plan, make sure they are correct. So you could build more types. I'm running out of time. So I'm just gonna test it in a new project. Create a wall, bring this cabinet, and all the different dimensional constraints should work as intended. So load into the project. And here it is. Shaded. And notice the default value is, the default height is always for 6. I'm going to switch this to a different type, etc. You can continue building it, and in the project you can define the material. So if you decide, okay, this material needs to be wood, just add the wood material into the family, and because the wood material is concatenated with the it's concatenated with the door panel and the shelf, the material should travel to the door and should travel to the shelf. I'm noticing that the door is not, the parameter of the door is not connected. So I have to fix that. Let me do that quickly. I'll select the door in here, edit the type, and then the door material of the door connected with the cabinet material. Then load into the project, override parameter values, switch to a 3D view, and let's build the cabinet material. Let's pick cherry again. There you go. And because it's a type parameter, it will apply only to that specific type. I'm going to change the material of this to something else. Etc. All right, a single family to define multiple types. You can see the power of nesting families inside of another one. You could have built this family from scratch and put everything in the same family, but then your floor plan, your family floor plan would have been so crowded with a lot of parameters, very dirty, very difficult to reverse engineer. But by nesting a family inside another one and then concatenating the values, then your family is cleaner, is easier to understand, it's easy to reverse engineer. It takes time. I mean, we spent 2 classes on this one because I've been going very slow. It doesn't have to take 48 hours to build this family, but as you get familiar with this, you can build this very quickly. All right. So it's past my time. Any question? The final version, it's on Google Drive. Feel free to open it and study it. If you have questions, you can stay over and I can look over your shoulder into your workstation. But if this was clear, let's end the class here then. And for Thursday, we're going to review phasing and design options. So make sure that you, in preparation for that, download the data set under the phasing and design options. And we're going to cover both topics at the same time. All right. Everybody have a great night. Check the recording. I'm going to stop it now.
Thank you.
Okay. Thanks, everyone.